or X's. Depending on who you are, you might use dots, you might use X's, depending on the information that you have. All right, you're going to get glue in. This first glue in, you're going to either glue on the left or the right side. It's your choice. You will need to show some work. Thank you. Appreciate it. All right, so we have two examples here that we're going to do with dot plots. So go ahead and glue that in either on the left or the right side. If you want to use some colored pencils, you could just grab a couple today. We'll kind of go through our work. Alright, so give you about 30 seconds, get that glued in, either on the left or the right side. We're going to show some work on the other side, so don't glue it right in the middle. Alright, so as we look at this is a dot plot. First off, this first part, this minutes to run 5 kilometers, that's called the title. That's a really important part of all of our work as we work on our displaying, is we always need to know what our numbers are about. So that's our title, where these numbers is what we would call the data. And then here we actually have our dot plot. So it's kind of 3 different things that they give us in this information for this first problem. They give us the title, and here they actually listed the data and gave us the dot plot. And I did that on purpose, where I gave you the data listed out so we could kind of see how those things match. How does our data match that dot plot? Okay. So as we take a look, we're going to go through and we're going to find our minimum. To start with. So what number would be my minimum here? When I look at my dot plot here, I'm looking to see which one is my lowest number. Not which one has the lowest amount, but our lowest number comes all the way to the left side here. And what number would that represent? Yeah, 25. It's counting by ones here. They skip count, but each tick mark is 1. So our minimum is 25, which a 5K is about 3.12 miles. So 25 minutes for 3.12 miles is pretty good. Not crazy fast, but a pretty good time. All right, next up, let's find our maximum. Hey, you guys, do that later. All right, so next up we have a maximum. So if on our dot plot, if the minimum is all the way to the left, where is our maximum going to be? Yep, all the way to the right. It's our biggest number here. And we see that that is at 40. So that person probably maybe wasn't running the whole time. Maybe they ran for a little while, then they took some time to walk. Okay, do this with us. Hold on, do this. So you know how to do it. Do this with us. We'll finish that during work time. All right, our next part is that we're going to find is the range. How do we find range? Smash your phone away. Good, we do our maximum minus our minimum. So what is our maximum? 40 minus our minimum, 25. And we get 15. So our range is 15 minutes. And that tells you like how long did somebody have to sit at that finish line in this 5K. They had to stand there for 15 minutes between when the first person finished the 5K and when the last person finished the 5K. 15 minutes isn't that much of a difference. That's pretty crazy to me. So that tells me that generally maybe these are all the same types of people that are applying to this 5K. Our last one that we're going to do here is the mode for this one. Mode means what again? Good, most often. And the dot plot is really good for that. Mode is a really amazing thing to use on our dot plot because it's really just easy to see which one is stacked up more. So which one has the most points at it? Good, 32 and 38. How many 32s are there? 2. How many 38s are there? 2. So is there one that happens more than the other? Nope. They both happen the same amount of times, and they happen twice, which is more than the other. So our mode is 32 and 38. So as we work through in this unit, we have kind of two goals. One goal is to be able to read the display, look at it, find out those major ideas, those big ideas. And then the second part is to actually make it ourselves. What are you guys doing? Weird. Alright, so next up we got hits in a round of hacky sack. Okay, do you guys know what hacky sack is? It's like a 90s thing. It might be coming back. Who knows? Hacky sack, it's like a little like beanbag thing, and you hit it with your feet. You can hit it with your elbows. You just can't hit it with your hands. And you like stand in a circle, and then you play hacky sack. Okay, so when we say hits in a round of hacky sack, it's how many times were they able to hit it with their foot or their elbows or whatever before it hit the ground. Okay, it's kind of hard. I tried. I was in a hacky sack group. I used to hacky sack when I was in high school. We'd sit over by our metals room, the welding area. So first thing we're going to do is create a number line. And I'm just going to create this box or this dot plot over here on the right side. All right, when we create a number line, we need to decide what we're going to count by. If we're going to count by 5s, 10s, 15s, or just by 1s or 2s, or maybe by hundreds. So as we take a look at our data, what's our smallest data point that we have? 3. And what's our biggest?
12.
I think 12. So to go from 3 to 12, do we want to count by 1s, 2s, 10s, 15s, 20s? Yeah, probably just by 1s. So I'm going to start at 3, and I'm counting up to 12. So 3, 4, 5. I'm going all the way up to 12. You're welcome. So create your number line, having it go all the way up to 12. All right, what's really nice about a dot plot, or if you do X's, is that we don't have to organize the data in any way. After we make our number line, it's really easy. You just put a dot where you see the numbers. It's pretty straightforward. The biggest thing about a dot plot is you want your dots to be about the same size. So if I make one dot way bigger than the other, it might look like there's more of that. So try and make your dots the same size, or if you want to do X's, you can. All right, so I'm going to start at 11. So I'm going to put a dot at 11. You also want your dots big enough for your person to see them, so just putting like a little speck isn't good enough. You do have to make a little bit of a circle. Then the next number is 9. Then we have 6. I'm just going through our data and plotting those points. 12. We have another 6, so where am I going to put that 6? Yeah, we just stack it. We put it on top. So I have another 6, and yet another 6. There's 3 6s. $12. 3. And 4. So hopefully you didn't have to look up and down too much. You should have been able to look kind of at your own data and match where those go. All right, and that's dot plots. It's pretty straightforward. Do you guys have any questions about them? Pretty intuitive, right? I feel like it is. If you have questions, ask during your quick check today. It's going to be really important. All right, I'm going to draw a line across. I'm going to do this one a little bit darker because now we're going to switch up our topic. Instead of talking about dot plots, we're going to move on to stem and leaf plots. Now, stem and leaf plots are used mostly like in science classes. It's mostly when you're writing down data points, and especially if you're writing down data points quick, you'd want to use a stem and leaf plot because if you have really big numbers, the amount of time it takes you to write like a 5-number number. What is happening? Okay, take a deep breath. Calm down. You're good. All right. The amount of time it takes to write down a 5-digit number, the next thing might have already happened. So you might want to use a stem and leaf plot to kind of be able to notate that quicker. But then for an organized stem and leaf plot, it's usually just to save space is our biggest thing, is that we need to know the numbers, but we want to save space. So we have a stem. And when you think of stem and leaf, what do you think of? Yeah, a tree, bushes, maybe like a flower, some sort of plant. Okay, so we always have our stem, and what's connected to the stem? The leaves. So we have stem on one side, and we have our leaf on the other side. And on the leaf, we're going to list multiple leaves, and all these leaves are going to be connected to a stem. Okay, so I'm just going to tell you the basic idea before we take a look at that. We're going to have a stem, and then each leaf is connected to that stem. Okay, and it's a way to show data using place values. So that's kind of a different part that we're not used to, is that we're actually going to break things back down into like the tens place, the hundreds, the thousands. We're going to use those place values to show the data. Because we're using place values, the key today is really important with our stem and leaf plot. Not today, it's always. The key is our way of how to read it. And that how to read it is really going to change the context. It's going to give us the idea of different numbers. Are we working with really small numbers? Are we working with really big numbers? Are we working with normal numbers? Okay, and our last note that we're going to write here is that each leaf is connected to its stem. That's really important. Each leaf is connected to its stem. Thank you. Each leaf is connected to its stem. This one out of the two, this is the one that you want to really focus back in on. If you've zoned out for a second, re-wake up. This one is the one that's a little goofy. It's a little silly. Doesn't quite look like what we're used to. Alright, as you get your glue in, this is going to probably have to go on the next page, which is okay. So once you get your glue in, if you're ready to flip to the next page. This is the one that's a little bit sillier than what we're used to. So it's really important we take our time to read through it. We have 3 examples. The first example, we're going to focus only on reading it. The second example, we're actually going to find that minimum, maximum, mode, maybe our median. And then the last one will actually make a stem and leaf plot. All right, are you ready? I'm going to flip this.
No.
No? Yeah, I was wondering what was happening. I wonder why you're goofing off so much. Alright, I'm going to flip my page. You should have been writing it down as we were going. What were you doing? I'm ready to glue this in. Alright, you can glue it in on the next page, either on the left or the right side. Leave some space in the middle of your page. Okay. All right, so go ahead and get that glued in. All right, so this first one, what are we talking about? What is our data dealing with? Good, test scores. What do you notice about our test scores here? The highest one is 60. So do you think that this is like percents, like the highest person got 60%? Could be. But it's probably more likely that it's just their actual score out of 60. It looks like quite a few people got in the 50 range. So maybe the highest was 60 or 62, and it's just their score, probably not their percent. Or hopefully not. If it is their percent, that teacher needs to do a retake. All right. So as we take a look at this, we see it's about test scores. In this one, I gave you that data. That data is really important because we're going to be able to match that. And then there's a key. That data is not always there for us. So today, that goal is to focus on how this matches in that first example. So big thing here is our key. Our key tells us how to read the stem and leaf plot. And our key says 3, 9. What that tells us with 3, 9, and the stem is 3, the leaf is 9. So if those match, 3, 9, it actually means 39. So the stem is our tens place, and the leaf is our ones place. So if I take a look at 49, and I'm just going to color code this a little bit different, so if you'd like to color code this with us, as I take a look at 49, they're trying to break up 49 into 2 values. So how would 49 be broken up? What's the tens place of 49? 4, so it's a 40. And they broke it up into also the ones place, which is 9. So they're looking at 49 as 49. And to find that in the stem and leaf plot, we're going to go down to the 40 column. So the stem part is our 10. So this is really the 30s, 40s, 50s, 60s. So I'm going to go to my 40s. And 49 would be the 4 and then the 9. Those together make 49. So each of these numbers in the leaves represent a different number. So let's take a look at that 5 one, because it goes like 5 and it's like 2,355. And you're like, what? There's no 2,355 here. Each of these leaves are connected to the stem separately. So when I look at this 2, that actually represents 52. All right, then we have a 3. So what does that 3 really represent? 53. And what do those other 2 numbers represent? We have a 55 and another 55. Okay, so in that 5 row, it's actually 4 numbers. It's 52, 53, 55, 55. What does 60 mean? 60. Good. It doesn't mean that there's 0 6s. It actually means the number 60. We're just putting them together into one number. All right, so for this next one we're not given the actual data points. We don't have that list, so we can't double check. Here we could double check, oh, there's a 52, a 53, a 55, and a 55. Okay, so the next one we're talking about boiling point. What does boiling point mean? Good, the point at something boils. So when we talk about like water boils at, anyone know? 100 degrees Celsius. That's why it's 100 degrees Celsius. Yeah. I don't know, it says Celsius right there. If it's Fahrenheit, it's 212. Why is it 212? I don't know. Fahrenheit's weird. Celsius makes more sense. Okay. That's how I feel about some people, too. All right. So we have our degrees Celsius here. We're talking about our boiling point. First thing we're going to do is identify our key. Key is really important again. So this time we have our key is 1,000. 1,5 represents 1,500. What are you guys doing? Brian, Marcos. Brian, what are you passing? It was not a pencil. You can't do that in the middle of class. It's weird. Okay, so 1,5, we have 1,500. All right, so as we take a look at this, if I look at my minimum, my smallest number here, where would I locate that smallest number on my stem and leaf plot? Yeah, we're going to go to the top of the stem, 0, and then 0, and then it goes slash what? Yeah, our smallest one in that row is a 1. So I have to think, what does that mean? 0, 1. 0 represents the thousands, and the 1 is in the leaf part, and the leaf represents hundreds. So it would just be 0,000, so no thousands, just 100. Way up there. Sorry. And then our maximum. This is kind of where we have to start looking at our brain, because our maximum, we might see these 9s and say 9 is the biggest number. But when we look at our maximum, we have to look at our stem. What's our highest stem? 4,000. So our biggest number is 4,100, because it's in the 4,000 range.
Awake. Time to be awake at school, please. Time to be awake at school, please.
Thanks, Miss Albert.
You need to be awake.
All right, next up we have our mode that we're going to find. Mode means most. And again, when we look at this, when we think about mode, we're thinking about what happens the most often. And as I look at this, I might see that there's a 1, 1, 1, 1, 1, 1, 1. Here's a 9, there's 2 9s. But does that 9 in the top row match the 9s in this second row? No, because this really represents 900. This down here is 2,900. Hey, you two. This is why you don't sit next to each other. Okay, so when we look at this, we are looking for something that's the same in the same row. It has to repeat within the same row. Yeah, so these 1s all repeat in that same row the most. So that is going to be our mode, is those 0 1s. And since they're connected to 0, that means they're really just 100. All right, the last thing we're going to find is the median. Now, some people really like... Stop. Some people really like finding median using our stem and leaf plot. Some people are like, that was way more difficult than it needed to be. So it's kind of your choice, what you like. I don't know. Some people really like it. They think it's a little bit more organized. It's already organized least to greatest for us. So we just need to go into the middle. All right, so I'm going to start with my smallest. My smallest is this first 100. I'm going to use green to kind of show this, and I'm just going to underline. So that 100 goes with the 4,100. That would be our biggest, so those match. And I'm going to work my way towards the middle. So now I have this 100. Would match with the 2,900. 3 is here, but do we have any 3,000s? Nope. If we did, we at least would have a 0 or a 1 or a 2. What is happening today? Oh my goodness. All right, so now we have this 1. That's our third one. Goes with this 2,900. Then we'd have a one more 1. Goes with the 2,600. $300 goes with 2,400. 300 would go with 2,200. All right, then when we get to a new row, that's where it gets a little goofy, because when we go to 400, what is that 400 going to match with? What's our biggest number in this row? Yeah, with the 8. Good. All right, and in the middle I have this 9 and this 5. So what do we do if there's 2 numbers in the middle? Good. Add and divide by 2, but when I add them, am I just going to do 9 plus 5 divided by 2? Good. I have to actually use what those numbers stand for. So that 9 is not just a 9. The 9 is really a 900 plus, good, 1,500. And then we'll divide that by 2, and we'll use our calculator. This one you might be able to plan out in your head kind of where it is 900, where is 1,500. If you go to the middle, some people can think about that visually. There we go. All right, so 900 plus 1,500 divided by 2. We get 1,200 would be our median. All right, we have one more. This one we're actually going to make our stem and leaf plot.
All right, just a history fact. The US chose to use Fahrenheit because they adopted it from the UK. But then they choose to stay with it because they felt like it's more precise because there's more units to it compared to Celsius. Is what the internet says.
Interesting. Would have never guessed. All right, so as we do our annual precipitation, precipitation is just a fancy word for rain or snow. It's all the things, right? Anything that comes down that's wet. Okay, we're measuring it in inches. We need to first identify for our stem and our leaf plot, what do we want our stem to stand for, and what do we want our leaf to stand for? How are we going to break these numbers up? And the big thing is when we do this, we can only have one number representing the leaf. So if I take 54.4, and I just take off that last part, I would have to have a 54 over my stem, and then a 4 in my leaf. I couldn't do 544. That's not going to work. Leaves are always just one number. Okay? So I could do 54 and do whole numbers for my stems, and then do our leaves as our decimal points. But what is our smallest number here that we'd have to go from? 10, and then what's our biggest number? Oh, 9.8 actually. What's our biggest number? 68. Do we want to count by ones all the way from 9 up to 68? No, that's too much. So instead of breaking it up with that decimal, we're just going to break it up into our tens place and our ones place. But as we take a look at this, they're not all broken up into tens and ones, so we're going to have to do some rounding. Okay, so as we go through this, let's go through and just round each of these really quick. Remember, if it's 0.5 or higher, we round to the next number. If it's lower than 0.5, we round, we keep it the same. So 54.4, would that stay 54 or go up to 55? 54. So that's 54 now. 18.4. 18. 39.4. 39. 31.2. 31. Okay, so what we're doing right now is we're just rounding them to the nearest whole number so we can break it up into our stem and leaf. 57.8. That would round to 58. Those ones are fine. They're all whole numbers. 9.8. Round to 10. 57.2. 57. 46.6. 47. 42.8. 43. 52.4. 52. 59.2. 59. And 50.6. 51. Good. All right, so now we're going to use those whole numbers to show our stem and leaf plot. We go one by one. So now that we're doing it by our tens, we can start at 0. And then when I do 1, that would be the tens place. 20s would be 2. 30s. And how much do I need to go up to? 40s. Yep. 50s. And 60s. And I just have to go up to 6. So each of these represents the tens place. Now that we rounded, do I have any that start with a 0? Like any that are just a ones place, like 9? No, the 9 rounded up to 10. So we're actually going to start with 1. And what we're doing is we're looking for anything that has a 1 in the tens place. So we have this 10. Anything else that has a 1? The 10 next to it. Anything else? 18. So as I list this, we always want to go least to greatest. So my smallest is 10, so I'm going to do a 0. That represents 10. I'm just picking the second number. I have another 10, so I'm going to do another 0. And then I have an 18. The 1 is there for the 18, and I'm just separating it so the 8 is off to the side here. So I have 3 numbers that come with a 1. So next up we have our 20s. So let's identify where our 20s are first. So that's kind of our big thing, is we have to identify where they are, and then we do have to order them least to greatest. Do we have any 20s? Oh, perfect. Skip it. Okay, big thing is we can skip it by not putting anything there, but we still have to list it. We can never skip on the stem part. It's kind of goofy. All right, so with 3s, what do we got for 3s, the 30s? Good, we got 39, 31, 33. Is that it? Mm-hmm. So as I go least to greatest, what's my smallest 30? 31. then 33, and then 39. Okay, going on to the 40s. If you want to try and work ahead on this, if you're like, oh, I get this, this makes sense, go for it. And then double check your work and make sure that it matches once you're done. All right, so for 40s, got 42, 43, and 47. So least to greatest, what's my smallest 40s? 42, a 43 or 47, 43, and then 47. All right, then we have our 50s. There's a lot of 50s, so we have to be really careful with this one. So we have 59, 52, 51, 57. They're all the ones we rounded. 58, 54. Is that it? 6 of them? All right, so we're going to start with our smallest 50s. So what's the smallest range of 50s we have? 51, 52, 54, 57, 58, and 59. And then our last number is 60s. And we only have one of the 60s. It's 68. So that makes it easy. We just put the 8 there. Now we're not done yet. We missed the most important thing. In a stem and leaf plot, what is the most important thing for our reader? The key. They need to know, is this 1,000? Is this 1,800,000? Is it 1.8? What those represent. So we just pick a random number. Usually I use a number that's from my stem and leaf plot. So we put key. And we can pick any number. So which number do you guys want to pick from that we used? What? 39. So 39 was a 3, and then that was the stem. So we do that little line there to show that the 9 is the leaf. So 3, 9. When we wrote that 3, 9, what did that 3, 9 really represent? 39.